Welcome to this video of our series Exploration Explained, Students Talking About Deep Sea Mining. This video is all about cobalt-rich ferromanganese crusts. This sounds very complicated, but if you break it down, it's actually pretty simple. So let's get into it. Cobalt-rich crusts, more correctly known as cobalt-rich ferromanganese crusts, are found primarily on seamounts, ridges, knolls, and plateaus at ocean depths of 600 to 7,000 meters. The cobalt-rich crusts with cobalt concentrations of economic relevance are found at depths of 800 to 2,500 meters. These crusts are formed in areas of high turbidity, which usually occurs at peaks of seamounts, ridges, and other elevations. These underwater rises result in eddies that can trap nutrients and metals, which will eventually deposit on the rocks. The crusts form through the precipitation and deposition of iron oxide hydroxide and manganese oxide, also called vernadite. Other minerals build a bond with the slightly positively charged iron oxide when there are slightly negatively charged ions, for example the anion molybdate, or they attach to the slightly negatively charged vernadite molecule when they have a slight positive charge. Examples for this are the mineral ions cobalt, copper, and nickel. This is how the crusts contain so many different minerals and rare elements like tellurium, which is used for solar panels, as well as platinum and titanium. The formed crusts are very porous, with a high surface area in the crust, which provides a large area for minerals to deposit on. Most of these elements found in the crusts are originally eroded material from the continents. They are washed out by rivers and transported to the ocean. Only iron and manganese originate from the ocean. In the Atlantic, they are released into the water through hydrothermal vents found in areas of volcanic activity. And in the Pacific, they originate from upwelling cold seeps that are not connected to hydrothermal activity, except for some volcanic arcs. The growth rate of crusts is relatively slow, with a growth rate of 1 to 5 millimeters in 1 million years. Crusts can have a thickness of a few millimeters and up to 26 centimeters, so you can calculate for yourself how old these crusts must be. The name cobalt crust is a bit misleading, as cobalt crusts are primarily made up of iron and manganese, but they are the main sources of cobalt found on Earth, with almost 2% of the crusts consisting of the element. The manganese content is a bit lower and the iron content a bit higher than in manganese nodules. Cobalt crusts are found worldwide on the ocean floor, but the highest concentrations of crusts with economic relevance are found in the Western Pacific, also called the prime crust zone. Many are found in areas of volcanic activity and around islands. Therefore, the exploitation rights go to the corresponding exclusive economic zones, in comparison to the exploitation licenses delivered by the International Seabed Authority, who gives the rights to exploit mineral resources in international waters. This is mostly the case for manganese nodules and massive sulfide deposits, but this will be discussed in the video on the legal status of deep-sea resources. For the deep-sea ecosystem, cobalt crusts are habitats with a high biological diversity by providing shelter to many different benthic species through the large pores of the crust. Furthermore, the seamounts and underwater rises provide essential locations for reproduction of many different species. Many fish species, also commercial fish, have their hatching and nursery places along seamounts. Concerning the exploitation of cobalt-rich crusts, they are not easily removed from the seabed, as they are attached to the underlying rock in comparison to manganese nodules, which are easily extracted. This poses technical difficulties for possible future exploitation, because there is no machinery available yet that can separate the crust from the rock on the seafloor and transport it to the surface. Therefore, major destruction of the seabed is needed to harvest cobalt crusts at the moment. One advantage of cobalt crust harvesting versus manganese nodule and massive sulfide harvesting is that cobalt crusts are not covered by a layer of sediment, so the occurring plume while harvesting would be smaller than while harvesting the other resources. Retrieving the cobalt crust could eventually mean a loss of biodiversity and a loss of commercial fish. This is it on cobalt-rich crusts. I hope you liked the video and learned something. And as usual, you can type your comments in the section below. And if you have any questions, feel free to ask. And in the next video, we'll cover massive sulfide deposits, which are another resource found on the ocean floor. We hope that you liked the video and see you next time!